The final thing that we're going to look at in this section is the arc length function. It says if y equals f of x and if f prime is continuous on the interval from a to b, then by the fundamental theorem of calculus, we can define this function s of x, which is equal to the integral from a to x of the square root of 1 plus f prime squared dt. So we can set up a function that will give us the length of a curve on a certain interval, where a is going to be the starting point of that interval. So let me show you how this works. It says, find the arc length function for the graph of f of x equals 2x to the 3 halves using 0, 0 as the starting point. And I'm going to stop here and just do this first. So if this is our f function, I need to find the derivative of this. And in this case, I want to actually find f prime of t. So instead of an x, we'll just replace with a t here. So I'm going to have 2 times 3 halves t to the 1/2 power. Or in other words, I just get 3t to the 1/2. So to create my function here, I'm going to have s of x is equal to the integral. My a here is going to be 0 because that's my starting point. So it's going to go from 0 to x. I don't know what happened to part of that x, but we'll leave it be. Of 1 plus 3t to the 1/2 squared dt. When we square 3t to the 1/2, we're going to get 9t. So we have s of x, it's the integral from 0 to x, of the square root of 1 plus 9t dt. And that is our arc length function. So as long as we're starting at the point where x equals 0, this will give me the length of the curve up to any given point x. So we're told here, the second part, what is the length of the curve from 0, 0 to 1, 2? So we're looking from x equals 0 to x equals 1. So I'm going to replace the x in this function with a 1. So now we need to integrate the square root of 1 plus 9t. I'm going to use a u substitution here. I'm going to let u equal 1 plus 9t. Then du will be 9 dt. I do not currently have a 9 inside of here, but I can put one in by putting a 1/9 in front. So I could write this 1/9, the integral from 0 to 1 of the square root of 1 plus 9t times 9 dt. So I'm going to go ahead and do the u substitution. And I'm going to change my upper and lower bounds while I'm at it. So if t is 0, u is 1 plus 9 times 0, or still 1. Not still 1, it's going to be 1. When t is 1, 1 plus 9 times 1, we get a 10. So we have the square root of u. I'm just going to write u to the 1/2 power du. So this is very easy to integrate. We're going to have 1/9 times 2/3 u to the 3/2 power. And we're going to be evaluating that from 1 to 10. So 1/9 times 2/3 is going to give me 2/27. Plugging in 10 for you, we have 10 to the 3/2 power. Sorry about that, my computer's dinging. Then plugging in a 1, 1 to the 3/2 is going to just be 1. So we have 10 to the 3/2 minus 1. And actually, we can leave it just like that, because that 10 to the 3/2 is not going to clean up anymore. And there we go.